So let's continue our journey in drawing or plotting linear functions. So now let's show what happens when we use a negative slope. Yeah, and this time I would like to write down the general equation for a linear function. Now it is nothing complicated. We have y as the variable. I think I'll include the variable x equals, I'll use a different color for each. So let's go with M. M will go in green, yellow, pardon, multiplied by our X, and then depends on which school is plus, and I will use the number B. Yeah, it's just a number. So this coefficient right here, this is a coefficient. This determines the slope of the function, determines the slope, how steep the function is. How steep. And in blue, if I may, let's simply call it the determines this coefficient or number determines how the function shifts in the y direction. And the y direction is nothing else than how much it shifts upwards and downwards. Okay, so the blue coefficient determines if we shift the function towards the, well, upwards in the positive y direction, or if we shift it downwards towards the negative y direction. Okay, now that we have this basic equation explained, let's go draw some more linear functions. So let's begin with y as a variable of x. Let's go with minus x, and I will add a minus 1, okay? So again, we will start with a simple table, as so. And just to practice, I will include 3 points, even though you really need just 2. Okay, so let's go with a minus 3, let's go with a minus 1, and let's go with a 3. Okay, minus 3, minus 1, minus 3. Now, extremely important is that we have to realize that let's evaluate for the first point, okay? So we have a y minus 3. Now, be extremely careful. The first minus is from here, okay? The first minus comes from our function, which is right here. Only then we plug in our x. Now, our x is again minus 3, and then minus 1, which I will go in white. Now, it's crucially important because, well, we have minus and minus, and hopefully we remember that if we put, well, minus, it is multiplied by minus, and it becomes a plus. Yeah, minus minus becomes a plus. So the result, in fact, is a positive 2. A positive 2 is our y, a positive 2. Now let's do that again, just for sake of clarity, with the minus 1. Okay, so again, our minus sign is right here. We have the brackets, and we plug in our x value, and it's minus 1. Minus minus is plus. Minus minus becomes plus. And yeah, 1 minus 1 is simply 0. 0. You can sometimes see me writing 0 like this. It is essentially identical. But let's stick to the traditional format of a 0. Okay. And so we have a 0, a yellow 0 right here. And if you plug in 3, then it becomes minus minus. So why not? Let's go step by step. So if you plug in a positive 3, now we have only one minus sign, yeah? And we only plug in a 3 minus 1, which is essentially, it is minus 4. So again, let's draw a coordinate system, but this time I will draw multiple functions right here. So we're drawing a coordinate system that we know, x and y. I will just put the ticks. I will jump the numbering because I think it's hopefully it's very clear. I think I'll put 4 ticks. Always try the steps for it to be the same. Now we have the first point, which I will circle, is we have minus 3 and 2. So we go minus 3 and a positive 2. So this line is, the point is right here. This point is a minus 1 and 0, which is right here. So it intersects the x-axis at x equals minus 1. And then we have 3 and minus 4. Yeah, 3 and minus 4 we have right here. And then we draw a straight line. And ideally is that it crosses the minus 1 also right here. Now, this is our function that we drew. Now, again, let's try to... In fact, I think this is enough for this video, and we're continuing on as to what happens when we change the m value. So far we had only 1. This m value we had only equals to 1. And in the next video, we're going to cover how to draw the function if m, for example, equals to 2, or m can equal to even 1/2. It doesn't have to be a whole number. See you there.